For joining us with today's webinar. We're happy here at Macrofab and to have Xometry with us to talk about some of the challenges that you can face that will pause or create issues in your production, and how, as engineers, we can help to address those during the design stage. Michelle, if you want to advance this. So a little bit of background. My name is Chris Church. I am the co-founder and chief product officer here at Macrofab. I've been involved in everything from software to hardware projects, robotics, manufacturing over the past 20 years. And I lead here at Macrofab, I lead our product teams, our support teams, and our manufacturing engineering teams.
All right, and I'm Greg Paulson. I'm with Xometry. So Xometry is the world's largest global manufacturing marketplace, and I'm here to represent the mechanical goods, right? The molded, the cast products, the mechanical of that electromechanical. But my background is in rapid product development, so a lot of my life in the early phases has been in the creation of those specifications, the documentation, the initial design, and what we need to do to scale up. And throughout my career in Xometry as well, we worked through multiple projects of entry at any stage you could possibly think of within the production life cycle, and have burnt our hands to the stove a little bit, and also bring our lessons learned to our customers as well.
Thanks, Greg. We really appreciate you being able to join us today.
This will be fun.
So for our agenda, we're going to talk about what engineering change orders are, how they impact your production, and then we're going to talk into some major causes for engineering change orders. They are material availability, design for X, and by that we mean design for manufacturability, design for assembly, and design for test. And then finally, we're going to jump into documentation. So let's go ahead and get started on engineering change orders and their impact. So here at Macrofab, I probably should have clarified that a little bit. We are a manufacturer for electronic products. We're a cloud-based cloud manufacturing platform. And so a lot of what I'm going to talk about here is really thinking about electronics manufacturing. And when we talk about engineering change orders, they really can happen at any time during the product development cycle. But where we care about their impacts to the business is once we've already quoted and accepted that order, that's where new costs will come in. That's where new delays will happen in production, and they're typically they can be either triggered by the OEM, the company that's actually needing their product produced, or the contract manufacturer based on observed issues. And typically how these will be handled is what we'll have is an engineering change notice. Something needs to change. There will be agreement about the impact of that on the product, either the pricing or the timeline or both. And then there will be a final order that both parties agree to. And so what we want to focus on here is having changes during the quoting phase is okay, right? Because we haven't settled in on a price. It's not typically going to have a huge impact on the cost or the time of production. But once that quote has already been accepted, everybody's working off, one known model, and any changes we happen to have there that create new costs or new time frame, we now have to agree to those. And even the process of agreeing to those can sometimes add a couple days to your manufacturing. All right, let's go ahead and step forward one slide. So let's think about what actually drives those engineering change orders at the contract manufacturer. When we look at the sourcing phase, the number one cause is unavailable or long lead time components, right? During quoting, the materials were available, but now all of a sudden we go to buy them, the lead time changes, the pricing, or they're not available. That's going to create issues. We got to go out and find alternates, and we have to get those approved. Now, another thing that can really happen here in the sourcing is selecting a poor vendor or a process specification. So, if we're going to have something injection molded and we go to order that from someone like Xometry, who's going to provide those parts, and we find that the design itself doesn't really actually well map to injection molding, we're going to start creating a lot of delays. We're going to have potentially new tooling costs, et cetera.
Yeah, especially I know you're moving to that first article side of things. You have when you're moving to a production tool method, you usually have some chance for samples, but that does mean we're already cutting metal. So this is all about the preventative stage because to that note, when you have an ECO, I mean, there's some things that we call like grooming in production, which I think are the ones that are freebies. We understand, like we need to shave it off here to get a couple thou if needed. But there's other things where it's like I'm missing a hole or this does not mate to my particular part, and uh, that's price. So I mean, in our world, it's always about like what am I going to modify?
Mhm, mhm. And kind of thinking about oops, sorry if we jump back one slide here real fast. Looking at the first article. So we think about, once we've sourced all the materials, we're going to do a first article production, right? We're going to validate all these processes with the real production materials. We're going to try to put everything together here. And this is where we're starting to see issues around incorrect form, fit, or function. That PCB doesn't actually fit inside of that enclosure, or that screw boss is too long, right? We're going to see some issues there. But another huge thing that comes up here is incomplete or missing documentation. We got work instructions that said you do step ABC, but then when we're done doing step ABC, the product still isn't assembled or isn't working, right? So we've got to come in there and figure out what new steps need to be added to that process. That adds time, that adds cost to it. And finally, in the NPI, the tooling and assembly, right? This is the biggest, one of the biggest problems that we have at the contract manufacturer side is the tooling doesn't work, or the assemblies don't go together for various reasons, or they don't fit within spec. So here all of a sudden we're having to change the product. And then finally in production ramp, um, typically what we're going to see here are really around scalability and quality. Those are most of the issues we see. Hey, we can't produce this fast enough. We need to shave a couple minutes off this process, or we're getting, way too much fallout. We're getting, 20% error rate in this process, and it's driving that cost up, and we need to address it. So if we step forward one slide, where we tend to see issues as a contract manufacturer, and we produce thousands of products. I think we produced something like 5,000 products in 2021. And I've kind of went through the data there and looked at why we had ECOs, and almost half of them were for material availability issues. The next biggest cause was, a defect in or an issue in one of the design for X phases. And then finally, we see things like product spec changes. Sometimes those can't be avoided, right? Your customer has changed the way they're deploying the product. We've got to go make some adjustments to it, et cetera. But here, just looking at that, in 2021, material availability is our biggest issue. And that's also one thing where we find our customers are least prepared. So we're going to talk about that in just a minute, but if we'll go ahead and move to the next. So when we think about as designers, where should we focus our intent and our effort during the design phase to help prevent changes for an in-production product? There are a lot of different things that can go on out there, but really where we want to focus on is sort of the nexus of planning and control, where you can well plan for it and it's in your control as a design engineer. The only one on this list, and I've highlighted in red, we have design for X, documentation, and material availability. The only one you have little control over is the material availability, right? If we're talking about, a microcontroller that's being manufactured by one company, you don't actually get to control their manufacturing lines. I think with Greg, you guys have a little less problem with that material availability.
Yeah.
Um,
Yeah, we are because we're working on the mechanical portion. So these are housings, these are fixtures, pieces of tooling that you're, putting your PCBA into and creating your box build with. Uh, we're not constrained by typical hardware constraints like having, looking for a chip or dealing with those shortages. My biggest concern usually is those two in the upper right, that design for X. Like you are telling me your goals, so you're providing me with this file, and we're comparing what those two are doing, seeing if there's discrepancies or things that we need to optimize. Like, yes, I can make one, but if you want to start making this in the 10,000 plus, we should probably do some considerations here, or else we're driving, we're driving that, and that's controllable. The other side is documentation, documentation, documentation. I, when you talk about uh, supply chain resiliency. So just, hey, I have this product, I need it made, my source is kaput for whatever reason. There's a natural weather event, something closes down, global pandemics. One of the biggest challenges that we saw even in the last 2 years was that people who needed products didn't have the fully spec'd out technical documentation. It was kind of lost in tribal knowledge or held somewhere else, even in personnel that may no longer have been with that company. And that leads to huge bottlenecks and delays and almost having to reinvent a lot of this. So it's not just starting with documentation, but it's diligence, creating that virtual data package, if you will.
Yeah, and that's a, Greg, that's a great point about tribal knowledge. We see this a lot in the product assembly side where, a product is out at a contract manufacturer potentially for years, and that the OEM is really relying on that manufacturer to make changes, to make it manufacturable, to address issues. But they get to the point where they're letting the manufacturer control the documentation. And then, say one day they, for whatever reason, they need to switch manufacturers, all of a sudden, all that has to be rediscovered again. Because our assumption is always, the manufacturer has the documentation, they're going to give it to me, and they might, but it might not actually be useful for you or to, the new manufacturer you're working with. It may not be structured in a way that's meaningful to them. It may be
Yeah.
really developed around their processes.
And I can tell you that was one of my first jobs in the manufacturing world was electromechanical assembly. So putting stuff together, Kapton taping, cable harnessing, whatever you need. And our work instructions at that time, that was about 15 years ago or so, was printed out PDF. The PDF was created, and if anybody knows the rule, like once it's printed out, it's already out of date. Like
Right.
that's kind of the general rule there. But you're essentially marking and redlining like physically, on this, and you're adapting it. But at that point, control is gone if there's no diligence or, hey, all right, let's bring this to a version 2.1, and document when changes happen. So sometimes as a manufacturer, I probably are the engineers at that time when I was learning. Again, I was a tech, so I take no accountability here, but they probably should have bumped us a little bit and said, hey, so what are you really doing?
Exactly, exactly. But really, as design engineers, we can take the lead on making sure the documentation is as accurate and complete as possible. So let's go ahead and move forward. I think we're going to go ahead and jump now into material availability. Um, and this is the thing I have to admit, I spend more time talking with customers, internal team, than I talk about anything else these days, right? Everyone knows we're in a supply chain crunch on the electronics component side. It's a really challenging situation out there today. And it's one of the least controllable items. Again, we don't have any control over how other companies are consuming parts, how the manufacturers are making them, where our tariffs are going to be, when there's going to be a shipping issue. That's really out of our control. But what is our ability to set things like substitutes and alternates. When there's a form fit function, compatible part out there, it really makes sense to include it as an alternate. And one of the things that we're really seeing is that when we get a bill of material in quoting or even going into the NPI process, we're seeing less than 5% of our BOMs or BOM line items out there have allowable substitutes. That means we're not prepared at the MPI stage to have an alternative strategy around that particular component. Now, we do know that some critical components, right, you can't necessarily have a true form fit function substitute. If we're talking about, an HDMI video controller, right, or decoder, right, or you're a very specialized semiconductor, you may not have a allowable substitute, but there are some strategies that we can employ, and I'll talk about that in just a minute. And one of the things that we hear from customers all the time is, hey, when you quoted this for me, you locked in my material availability. No, that's not actually how that works, right? Your quoting process could take weeks or months, depending on the complexity of that product. And nobody locks anything in until there are purchase orders. Because especially in today's market, the distributors and the manufacturers aren't going to hold inventory until there's an actual purchase order out there, giving them the right to bill for that. And as a contract manufacturer, we can't issue those until we have a completed deal with you. Obviously, we can work, we work with our customers on strategic sourcing and ways around that. But typically, when you're working with a contract manufacturer, there's no guarantee of availability until the orders have all gone in and been accepted. And that leads me to that last point right there, is that I've never seen as many purchase orders with distributors and manufacturers get canceled as I have in the past year. That means literally we'll put in an order to buy something, we'll get an agreed price, and 2 weeks before delivery, they'll cancel the PO on us, right? Oh, suddenly we can't fill that order anymore, right? We couldn't get that line spun up, we couldn't build those parts. And now you're stuck scrambling to go back and figure out how to address this. And one of the real big, concerns we have, for OEMs when they're going into the production process, if they don't have an alternate strategy, if they don't have a way to address critical components, your only option once you're in production is to redesign the product around a different set of components. And if we kind of look at this graph on the right, this was a pretty rare event for us up until 2021. We started seeing a 6x increase in products in production that
Wow.
already have some production running, having to stop production for weeks or months to go back, redesign around a critical component that can't be purchased, you know, vet that design, go back through that engineering, go back through the first article all over again. And if you're thinking about like, yourself as a product designer, you are designing a product for a company to sell. You have orders for this product out there. If you have to stop production, go back and redesign it, the company's not making any money, right? You're not delivering any product to your customer for potentially months here, and this could be a very critical situation. So how do we address this? So let's step forward a little bit. Obviously, substitute coverage, right? Every part that has a form fit function equivalent, put an alternate out there. It's a little more work, it's a little more research on the design engineer side, but it's going to solve you a lot of problems because they're already baked in to that quote. So that you're giving people, the manufacturers, a strategy and a responsibility to handle that. Another thing that we can do here, because our prices get locked in, but the market changes, and it can change very rapidly today. We've seen prices change on a daily basis in some cases for some components. And again, nothing's locked in until those purchase orders are in there. So one of the things we can do is what we call PPV coverage, which is purchase price variance. So you can actually say to your contract manufacturer, hey, I'm going to give you 3 to 5% purchase price variance coverage that says you can spend up to 5% more on any given component without having to come back for an ECO. And just kind of looking at, production RFQs we got in 2021, I analyzed 500 out of the whole set. 75% of those RFQs we got had no BOM alternates whatsoever. Of those that had no BOM alternates, 85%, we had to go back to the customer during the quoting process and find alternates because the materials weren't available. And then out of every RFQ that went in and we processed, 28% had something go out of stock either during purchasing or during production, right? So this is a real big challenge for everybody. And the more we can do with alternatives, the more we can deploy these strategies, the less likely we are to have these issues.
Yeah. And I was going to say on this, like, on our mechanical side, as you're showing me this, like, the material availability, it was a little bit, it was different for us, right? Like on the hardware constraint. But I am getting kind of reminded, and sometimes not the best way, like on what we were doing behind the scenes. So with customers, it's kind of interesting, especially when looking at production, because sometimes you can speak in generals and we'll help you figure out what that specific is. Like at ABS, there's thousands of resins out there for that. And it also depends on, are you using international? Like, or are we sourcing this tool out of China, or are we building it domestic, and where that's coming from? So a lot of that change is actually part of our kickoff, but it is like the motions, like we're using, our knowledge of the marketplace. And I know on our team, for some very specific things, especially for medical devices, you need certain quality grade work. Like we did projects that required a CNC machine medical grade peak for a project, and we had actually ended up becoming the supplier. Now, luckily, Xometry has something called Xometry Supplies, so it wasn't out of our realm. We just happened to
Yeah.
have a supplies and hardware store, but we were able to supply the material for that, for the suppliers across our network that are performing the work to make sure that it was consistent, because our individual suppliers did not have the reach to really
Right.
get those goods, especially at any like economical price. And that was like something
Yeah.
where we really saw that roll in the last year, as you mentioned, is
Mhm.
how strong our supplies team played a role, especially in critical production products.
Yeah, and that's, and that brings up a good point because, we have what we call a strategic sourcing team in-house.
Yeah,
So
same here.
when we can't buy on the open market, right, we go to strategic sourcing and we can solve a lot of problems there, but it's at a higher cost and typically at a longer lead time, because, once we start going out into strategic channels, we've got to do part validation, we've got to check them, make sure they're not counterfeits. There's a pretty heavy process involved in that. So we always want to kind of avoid going there, but sometimes you can't, right? There's that one part that just can't be gotten and there isn't a good alternative for, and we have to go find a way to acquire that for you, including calling somebody else who's using it in their product and negotiating with them to give us some of their inventory. It's not an uncommon thing these days. So if we could move forward to the next slide. One of the other things that we can do here, and this is something, I myself, I don't do as much electronics design as I used to, but I used to design a number of products. And this is something where, we really can think about our active components and how we use them, and especially around things like microcontrollers, stuff like that, considering the family of components. Because a lot of times you'll find specific models within a particular family have more or less availability than others, but you may find that they differ in the amount of memory, or they might differ in a function you're not even using. So you can pull from that family where possible, and you can start asking questions like, hey, can I cross-compile my firmware to work on this whole family? Can I put device-specific checks in there? Another big thing you can do here is plan for feature degradation. And again, not every product is this, we're not talking about a global thing you could do in every product all the time, but these are some of the strategies we can use. And thinking about degrading functionality when certain materials are unavailable. And I can give you a great example of this. Early on in the pandemic, Ford started shipping out cars without the eco controls in them. Why? Because they couldn't get the PCBs, the parts for those PCBs. Well, they're still selling these trucks without that controller, and they're saying, look, when we get it, I'll ship it to you and put it in there. And we can take that same thing, right? If it's possible, if the customer I'm shipping this to doesn't need one feature, and if I can plan to degrade that kind of feature because it's not used by all of my customers, then I can do that in the design stage. For example, I can have a network of components that I enable or disable on material availability with a 0 ohm resistor, acting as a bridge, right? And then tell my manufacturer, here's my 2 variants. If I don't have this, don't pop these parts. Those are something we can do. We see this quite regularly, actually. That's a common response from some of our more advanced customers. So let's go ahead and move forward. Another thing here, and I'm actually surprised I see this less often than I would expect, but it's highly possible to, in many cases, to buy the same part with a different footprint that fits in the other footprint. It's a common enough activity that TI actually has a whole white paper and a guide on how to do this across some of their power control components. So we'll see on the left, this is from TI, how you can fit some different components in to 2 different components into the same area. So you can pick and choose based on availability, which you're going to use for a particular build. And on the right, we see a little more complex design where we have a MLF64 sitting inside the footprint inside a TQFP64. So these are strategies we can employ, and we can, as designers, bake them into the product to open up the material availability and our alts that are available to us.
Chris, I got a question on this slide
Yeah.
here. So the left-hand graphic, is that essentially two configurations of the board. So if this is not supplied, run this configuration of the board. If this is supplied, continue with this configuration. And the write is essentially just a single configuration that says, hey, I column A or option A, option B,
Right.
whatever, just use one.
Right. So the cool thing about both of these is the centroid of these parts are all exactly the same. So you can literally call them out with the same designator and have the two different parts as alternates. So you could literally run a mix and match on a line if you wanted to.
Interesting.
And that way you don't have to create these hard variants that
Yeah,
say I've got, U1 being popped in this variant and U2 being popped at the same location. You can literally call them both U1 in your bill of materials and have them have the same centroid just with two different parts in the alternate list. And that'll
that's
save
smart.
you a bunch of time and
That's
effort.
super smart. Yeah.
Mhm. And so let's go ahead and move forward. So kind of, wrapping up, oh, sorry, not wrapping up. We're talking about mechanical components. This is also where Greg's world is. Um, just to kind of, touch on this from the contract manufacturer side, we hate single sourcing. Single sourcing is a problem for us. You say, hey, it's a screw, right? Just buy it from this one place. Well, can I buy it from five other places? Because that one, their warehouse may be iced in right when I need them to ship if it's in the middle of the winter, right? Or there could be a trucking strike or something that just prevents us being able to buy from that vendor. Um, and I want to speak a little bit to single sourcing. We tend to think buying the same part from two different warehouses or two different distributors is giving us supply chain diversity. Well, the reality is today we learn you can go all the way upstream. That manufacturer that manufactures that component and ships it to those two distributors can run low on the materials or have a staff outage and have a problem. You're not really single or dual sourcing if you're just buying the same manufacturer part from different people. You really want to look at your supply chain and say, hey, can I get different manufacturers, not just different sellers for this material? And one of the things we talk about, the tooling and fixture issues. We talked about that could be an issue during our MPI phase. Well, consider building those and starting to build prototypes of the toolings and fixtures you're going to use during the design phase, right? Because you don't want to get to the point where you think everything's going to be great. We're going to go ahead and build a fixture, and then the PCB won't fit in it, or one of those pins won't line up. And now we got to go back and rebuild this whole fixture again. Keep testing each part of that process as you make design changes, just so you can be fairly confident that there aren't going to be any major issues as you get into it.
Yeah, absolutely. And by the way, I mean, I see, you know, fixtures can be as simple as, like a nice little, grid block or something like that. But this is where additive manufacturing really plays a huge role. Is a lot of these checks and fixtures, at least for the mechanical components, assembly enablement tools. Additive is just awesome. It's just awesome for this type of work. We even have ESD materials that you can 3D print to work with that. I will also say something that's interesting that I used to do in previous life was testing the physical fit check with additive manufacturing on the PCB, like literally making just a plastic mock-up of the PCB.
Mhm.
And you can do some kind of tricks of the trade if you're able to export a 3D model, where you can essentially just thicken the PC board just a little bit so you have overlap, and then you do a Boolean combine, and now you have a solid,
Mhm.
piece that you could then 3D print, and it can actually tell you some stories.
Right.
If you have the opportunity to do that, especially when you're working through work instructions where you're just thinking, hey, this should slide into this, CNC turn shaft here, and you can actually try it. Or like
Mhm.
if you're buying off-the-shelf extrusion and post machining that for your housing, it could give you a lot of information very, very quickly and relatively affordably. It's like an insurance policy there. Yeah.
Yeah, and that's actually, to build on that, we have used actually 3D printed variants of designs to test fit in processes before. Because one of the big challenges we see, like in alternates, is we'll do something like, say, a big electrolytic capacitor, right? Your alternates, they actually have two different heights, but you never think about that as a design engineer because you're focused on the primary one. All of a sudden, we build with that new alternate with that second height, and it doesn't fit in the enclosure, right? The whole product doesn't go together, or wire needs to be rewired.
Flashbacks. Yeah.
Um, we see that a lot, and yeah, and like to like Greg's point, our first article assembly facility has an entire array of 3D printers to create things to fix problems in the process instantaneously, just for that reason.
Yeah, and I was going to say that again, this is about preventing that, but
Right.
there are ways that you can incorporate additive if you're caught in the middle of something and you need to do a modification. Like your MEs may be looking at the chassis that they have built and be like, okay, so what's mounting locations do I have? How can I 3D print something that can push this board to an angle up here and then give me a clearance or allowance this way? And we've seen that done before. And again, it works. It's Band-Aid. Hopefully, on V2, you're preventing more, but that's something that a lot of times you'll see in that initial you're moving to your initial product, like first deliveries to customer, those type of things where you see some of that work happening.
Yeah, absolutely. All right, if we go ahead and go to the next slide, just to sum everything up, right? We got to identify what our critical components are. Then we have to identify the component risk, right? What are the historic and present market availability? I know I didn't touch on that, but there are a lot of tools out there, whether we're looking at the IHS data or things like Octopart, Find Chips, et cetera. We can actually go look at what the current market availability is. And by the way, the MacroFab platform will show you that for your BOM and in real time. Look for where we have issues with single sourcing, right? Do we have a high product complexity? And one of the things I didn't touch on here, but people care about a lot is pricing volatility. Actually, I did touch on that. If the pricing for a particular component swings a lot, we can plan on that in our design phase and understand that we may need to have alternative strategies or explain to our purchasing team that price is going to be highly variant on there. And then we develop our response strategy, right? Are we going to have alternate components? Are we going to have alternate suppliers? Are design variants the right choice? There's a lot of different strategies we can employ, but the key thing there is we can, as a designer, identify potential risks for production, create strategies for that, and execute those so that our products actually go into production and stay into production on the schedules we want. So we'll go to the next one. All right, now's where we get into, go ahead and jump on. Yeah, we're gonna go to design for manufacturability, design for assembly, and design for test. So when we talk about design for manufacturing, we're really thinking about the processes to manufacture the elements of our product, the tools that are gonna be used in that, and what kinds of machines we're using in that. When we talk about design for assembly, it's really about putting all of those components together into a final product, and humans are a major part of that, right? We're gonna be thinking about how does the human interact with this product, what does their workflow steps look like, and then design for test is how do I validate that this product works properly, when it's being built, and that it's going to be reliable in the field. Now, if we look at on the right side here, there's a little graph. We think about, during the production stage, we talked about, NPI earlier, which is we're doing the new product introduction, the first articles. Then there's sort of a mid phase, right, where we're ramping up to volume production. And then finally, in our later volume production phase, during NPI, the most common cause of change orders is a failure to do effectively design for manufacturing, right? This is where we're seeing this doesn't fit in this tool, right? Or this tool is breaking constantly when we're trying to use it. This is where, we just can't quite get this process tuned in yet. But once we move into the ramp stage, design for test is where we find the most issues, right? We're seeing too much, too much fallout on the quality side, where it's taking too long to test. We just can't get to where we need to be. And then finally, in volume production, we tend to see very few ECOs in the volume production phase. We always want to work those out during the NPI and the ramp. So here, any one of these sources can cause the ECOs, but typically we have worked those all out in the earlier stages.
It's just something interesting. So I saw this earlier too when we were talking about production ramp, and you see those columns are all the same height. But what's really interesting there is that yes, all these have some sort of equal play because I'm at such a volume now that any of these can cause a delay, but that delay is throughput. And I think
Right.
that's something that's really, really important there is, yeah, like, I'm now, everything I do, any single delay is now multiplied by the thousands.
Yes, exactly.
And that throughput, so it's not just, okay, my parts are coming out slower, but that's my deliverables to my customers. That's the thing that's waiting for that stuff to be made. And I mean,
Mhm.
so these are headache items by the time you're that
Mhm.
that far down. And I think it's interesting because, like, although they seem like lower and equal, they are just so compounded by volume
Right.
that they're
Yeah.
huge. If you're still stuck with some of these things, and we're going to go over
Mhm.
some key traits there for sure.
Yeah.
Um,
So let's go ahead.
just one thing, someone asked a question. I would request, I think it was relevant when
Mhm.
the presenters were talking, but the question is too short to make any sense at this point. So it says ref designator. So whoever asked that question, if you can, um, um,
Maybe we're talking about like revisions, like if I'm changing
yeah,
my rev midstream, like that could probably be
Well,
like revision controls, is something you would
no,
do
no,
with your.
the ref des is when I was talking
Oh,
about
sorry.
putting two components on the same point. They have the same designator. That we call it ref des or reference designation.
yeah. So if you can expand on that question, we'll be able to answer that question. And to everyone else too, please use the question section in GoToWebinar and ask your questions.
Hmm. Yeah, actually, in the database, one of our databases, it uses ref des instead of designator too. So let's go ahead and step forward onto the next slide. So thinking about design for manufacturing, right? There's a whole lot that goes into producing a product, especially an electronics product. We have PCB fabrication, we have PCB assembly, we have mechanical fabrication, we have the process that puts it all together to create that manufacturable process. And almost all of the issues we see, not all, but the big significant chunk there are about pushing process limits, right? When you've got a super dense PCB, you're thinking about, a compute product or a communications product, a wireless product where we might have hundreds of components per square centimeter. We're getting into some real issues in the process itself. I mean, outgassing from components can cause issues to the reflow of other components nearby. Some things can suck out heat, et cetera. So those are things, as we start really pushing the limits of the process, that's where we start finding issues for design for manufacturability. And we really have to start taking the tools into account and creating alternate strategies for dealing with that. The other thing, and I think I'll probably let Greg talk about this more, but designing our mechanical features to process minimums is, oh, I need that to be within 1,000th of an inch of tolerance. Okay, it's doable, but to what degree?
Yeah. So this is and like this would be like going to advanced auto parts and be like and asking like, how thin of brakes can I buy? Like that's like your yes, I can buy legal safe thin brakes, but I am incorporating risk into my goal, my project, right? Inherently by doing so. And we see that in design for manufacturing all the time across multiple processes, from like machining to molding, casting processes, and all over additive manufacturing, even though that's typically one of the more forgiving of those categories. But when you do have that question, like how small can I X, how thin can I X, like those type of questions, they are the possibilities. They are the things that I can do. And actually, yeah, I think we could jump to the next slide here because I think I have, we have some notes on there. But they are possible to do, and in low volumes, you can build these critical features fairly regularly, and you're because a lot of the cost is in the tooling and setups there. And actually, if you want to advance one slide, I think but we have, you know, it's possible, right? But as you look into production level environments, as we said, every single one of those little things that causes delay or specialized tooling or a specialized inspection requirement if it's not necessary and your product can still succeed, you may want to take that option, because you are removing risk in that downstream, or you're removing time delay. You're removing something that can sink time, and at that point in production, a lot of the cost of your parts is actually in those little things now. Like, it's and it can play a huge role in like how many can we make a day, how much, like what's our delivery schedule is going to look like. So a lot of times, I like this. I like this. This is actually a snippet from another webinar we did of Macrofab about when to get involved in that design for manufacturing stage, on the production stage. And our I think for both Chris and I, it's the same. Don't put off these manufacturing discussions while you're prototyping. So while you're working at low volume stage, while you're even digitally prototyping, you don't always need to make a physical good. In fact, actually, there's a lot of fantastic software tools out there. You can start having these conversations with your manufacturer. I know for us, when we talk about molded projects, we love to have that conversation while that iteration is happening, often on the 3D printing side. Because as we're doing that, we're talking about design for manufacturability, like molding, uniformity, undercuts, draft, like these really important things that 3D printing, you could get away with not having it, but we don't want you to have a massive engineering change when you're ready to press buy. Like we want you to be building and integrating towards your final process along the way. So we were talking a little bit about materials up front, and actually this kind of falls in the DFM too. Like when I'm prototyping, the other thing I wanted to note is sometimes I am switching processes based on what my goal is. So in this case, I am talking, right now this graph is kind of, biased towards plastic part production here. But if I am testing a material, I can, often match one-to-one materials, but sometimes it's not necessarily the material, but the property. So if you're trying to do a test for a fit or a snap, even though like this item may ultimately be a like a material like ABS, if you're testing snap, we actually, if you speak with like some of Xometry's engineers or look at some of our capabilities page, you may actually find that there's flexible materials that mimic those properties very similarly to ABS without actually being ABS. In fact, actually a lot of times it's materials like nylon and things that print more, are more forgiving for cantilevered features than a filament-based process, for instance, which is usually where you find ABS. But all of this comes to say, like when you're doing these iterative designs, we want to be working with you on that conversation. You're going to be actually able to get pricing. And as I said, even when you're digitally prototyping, we have things like we have our website, which you can always upload your CAD and get feedback. But even stuff like add-ins for SolidWorks, Inventor, and Fusion 360, you can start kind of at least seeing some of that digitally as you're working along. And we could jump over to the next slide here. So
the question, I got the question. I just want to. So apologies, Ray. The question appeared only half, but I can read the whole question now.
Sure.
So the question is, how would you handle the solder stencil when have two parts with alternate footprints at the same ref designator? And then the further, thanks Ray again to type this out. For example, are there two different solder stencils, one for each part, or is there one superset solder stencil?
Yeah, so when we're using two different footprints, how we do the stenciling is gonna matter about how the larger component is designed. So in the case, you can't really use for example, the the two parts over each other when there is a big, thermal pad, thermal ground below the larger component. That just really isn't going to work there. But when that isn't there, and we're not talking about something like obviously not like a BGA component, but when we're talking about a leaded component, there's typically going to be some height off the board for the leaded component. So we have two options there. One is we can actually, depending on the process, the overall complexity of the board, we can actually paste both footprints in some cases. But when that's going to be an issue, how we'll typically solve that in manufacturing is actually pretty straightforward. If we can if all of the stuff will allow us, we'll actually have both footprints cut out of the stencil, and we'll Kapton tape over the one we're not going to, the inner one we're not using. The outer one typically doesn't matter as much because there's nothing to interfere with there. But if there's going to be interference with a larger part by having put paste on those pads, or if we're concerned about we're not going to be able to get good flux movement out of those lower pads because it's really tight, we can then actually put Kapton tape or any other strategy there over those actual holes in the stencil at stenciling time. And that's just a lot faster and cheaper as long as it's going to work. Again, there's some designs maybe where we might have some stepped pasting that won't let us do that, or stepped stencils, excuse me. But outside of that, we're gonna try to optimize for the lowest cost to the customer while still providing that flexibility.
Yeah, and I think there's analogies similar to that. When we talk about specialized tooling, right? And actually, if you want to, you can progress the slide as well. But when we talk about specialized tooling, so sometimes in these low volumes, as we said, like can I build that? We may be using generalized tooling. We may use thread mills, custom thread, or we may do different contours to surface a part at low volumes. But with with production levels, I may opt in to pay more to have a custom tool that reduces a few operations and steps and gives me a more consistent finish. And it's always that volume as what reduces the overall lowest cost or hits my throughput goals. Like there's just two different goals there.
Yeah. Hey, Mitchell, let's advance the slide.
And this is just this is a handy reference, but I did want to show like that a lot of your spell checker, first off, the digital space is very, very important, especially now with CAD tools, like they're just so powerful, as well as, the marketplaces like Macrofab, they have a fantastic resource where you could go and see, alternates and goods and have kind of a bomb checker, which is pretty amazing. Like, I wish I knew, like I said, I wish I knew about that back in the day. It wasn't around then, but that's really exciting. And in my world of the mechanical goods, it's very similar. Like, what's my insurance policy, right? Like, what am I using to validate early on? Because I could tell you that even though sometimes prototypes seem expensive, it's way more expensive either in the actual cost of the ECO or the time lost, that wait time because of a delay in action than just just validate up front. But for example, these scale process like plastic injection molding, like we can actually make a mold. We could just make an aluminum mold, a lower cost mold for lower volume production if you have a specific material. If you're more general, additive manufacturing is certainly an option, and the surface finishes of that AM parts has significantly improved. So it's not always like a kind of a coarse, rough draft anymore. You can get some really fantastic results with that. And urethane casting is kind of like that in between, usually like sub 50 units. So for that, these metal processes, sometimes just machine it, is a very good option. And we also have metal additive processes that can help substitute, particularly for die cast and MIM components. Die cast, DMLS, and actually for die cast and MIM, direct metal laser sintering, 3D printing is a fantastic substitute, and honestly sometimes outperforms the die cast option in the end there. But I love CNC because it's just like looks like a duck, quacks like a duck. CNC machine it. We can scale with that. But it's there's the techniques we use. Even when I'm moving from CNC prototype to CNC production may be different, but at least you can validate those results in very low volumes, and it's really good for those critical fit checks for checking for assembly issues. You already have your jigs and fixtures ready, like they're available. We were talking before, like you could actually prototype your whole like bill of materials and just kind of check the movements around. So there are techniques to get physical goods as well as well before you're even invested in like the hard cut steel tool, for example. Let's move to assembly here.
Yes, design for assembly. I think Greg, you and I both live in this world on a daily basis, right? The two big things drive problems here in the assembly phase is they are our assumptions as a designer and an inability to match the scale of production to the process you're choosing. This happens, I hear this more often than not. A design engineer says, well, the line worker can make a decision as to whether that's a good fit or not. They can't, right? They are going to follow instructions, and in many cases, even if they could make a better decision, they have to deviate from the process, and that becomes an escape that factory will get dinged for, even if it makes a better product, because we're not building what we're supposed to be building. So we have to think about when things come up is can we provide guidance on how to resolve that? Like, for example, if two parts need to fit together in a very specific way, can you make a poka-yoke that says you can't make it through this test unless those are fit well, right? We don't want to leave it to someone like, look at it, does it look right? Do you think that'll fit? No. Give them something very, very specific that's a go, no go kind of test. And, reducing steps, right? We want to make it repeatable, and we want to get as many steps out of here as possible. Because the more steps there are, the more opportunity for failure there are, and the more, potential cost there is in that product. So reducing components, especially mechanical ones, will
Yeah.
really, really help with that.
Reducing fasteners, you usually see a lot of the, if you're mounting your PCB with plastite screws, so like thread forming screws in your plastic, which I love, by the way, I love plastite screws. But you're like, depending on volume, right? At first it's like, okay, cool, I have 4 screws, and that's it. But then multiply that by thousands, and you have huge manual burden. Could you integrate, an overhang, some location pins, and maybe just use 1 screw instead of 4 to make everything hold in place? Or even better, integrate in a snap tab at a slightly higher tool cost. I could put in mounting features without actually adding hardware. So there's really, there's design techniques where all of a sudden you could consolidate and even eliminate hardware from, or at least part counts of your hardware, not everything. Very, with a little bit more design forward thinking.
Yeah, and the other thing to think about there too, you mentioned the screws. As design engineers, we love screws. They're easy, right? I can put it in and go. Every screw requires a torque spec. Every torque spec requires a calibrated tool to execute that.
Yes.
What you're going to have, right? If you don't have a torque spec on that, your first thing that's going to happen is during ramp, we're getting fallout to cracked plastic bosses, right? Because it says there's no torque spec, just do whatever, right? So they use a hand tool, and one strong guy is going to be in there every day. I got it, and crack that thing, right? So we're going to have torque specs on all of those, or we're going to end up with an ECO that says, hey, I have to go and specify a torque spec and now a calibrated tool to execute that. So reducing those kinds of, any of these components can actually have a whole knock-on effect into the complexity of the process. On the right here, we're actually running short on time, so I don't get to spend too much time on this one. One of the things that we as engineers do is in prototypes, things work great, right? I can use cyanoacrylate to glue these 2 plastic pieces together. That's great. What if I'm doing 10 a week or 10 a day? But when I'm doing 10,000, I've got a big mess on my hand, right? Because even with the best, tooling out there to dispense that just right, people are going to make mistakes. We're going to get, fogging and off-gassing off that cyanoacrylate. So that works, our adhesives and solvents tend to work very well at low volumes, but, as we're trying to, we're planning to scale up and ramp up that production, we have to find another alternative. So, for example, sonic welding, I love it. It's a great process. It's really easy to scale up. It's low cost. Even the tooling isn't that expensive for it. Your horns and sounders, they're all, horns and anvils are actually really, really cheap to produce, except if you didn't design your product to be sonic welded, right? We get this all the time. I glued it, now just sonic weld it. Well, no, we have to guarantee a friction interface on both halves of that, right? If I'm doing hot plate welding, which is great, I can do 50 products at a time in one fixture, but is your product designed to fit in those kinds of fixtures and not interfere with the interface as it's coming together. Otherwise, we're going to have lots of challenges. So thinking about the kind of process we need to build this at the scale we want will drive our design to where we have to do certain design changes to make it successful using that process.
Yeah. This is also just on that note why we'll probably ask you. So say you have an initial run of like, let's just say 700 or something like that. We're still gonna dig in and see and ask you what your estimated annual volume is, because that stuff may not be intuitive to you, but if you give us a number that says, oh, I'm hitting several $100,000 or 700,000 a year, all of a sudden every single thing in my mind is going to how can I eliminate steps, to hit that throughput, and that's where these things really come to play is just how can I get deliverable units for you on a regular basis to fulfill the your blanket purchase order. And we're going to want to work that way down the line, like before cutting tools, like in the DFM process.
Absolutely. And so we're running pretty tight on
I know.
time. And
Yeah.
so let's go ahead and, Michelle, let's jump all the way to the documentation section. It'll be a little more interesting, I think, than the design for test at this point, because it'll take a little while. But documentation, this is the most critical thing you can do as an engineer when you're designing your product, is keeping the documentation up to date at all points in time. If you make assumptions about how it's going to be assembled, go ahead and document that, right? And then you come back and edit that as we learn more and as you're doing more design. Because, again, at the end of the day, if it's not documented, it's going to have to be discovered. And if it has to be discovered, this is where issues can now happen. And I think, Greg, you had a good point earlier about the red lines and the changes and actually maintaining rev control over your documentation.
Yeah, it's absolutely. It's just so important, and actually something that we do as a supply chain consolidator, right? I think both like Macrofab and Xometry were very, very similar in these aspects. Is we kind of have the master view of the technical data package, and that allows us to understand the ins and outs. And obviously, like some of these technical drawings and stuff are coming from you, the designer, the sourcing procurement. But we're able to dispatch that and qualify against that to our supplier base. And it's really important to have that. And also for you, it's a strategic importance when you're working with marketplace manufacturers because we have redundancy. We have those, we're able to work in disruptions in different geographic locations and work across the globe as required. So we become a supply chain solution as long as that documentation is repeatable, right? As long as that technical package is solid. Yeah.
Exactly. Well, I think we're reaching the end of our time here. So, Michelle, do we have any questions? Anything we might have time to answer?
Not as yet. There were two that we have already answered. I think at this point we might want to wrap it up. Okay. For folks who are on the call, appreciate your time today. It's a bi-weekly webinar series that we guys run. It's every Thursday, noon Central Time. Please keep joining us. As you can see, there's a lot of really good information that's being spread out via these webinars. We have experts coming onto this call. We have Xometry. Some point we'll have speakers from Altium come and speak with us. So the whole point over here is to work with the community, answer questions that might be out there. So keep joining this. This webinar will be available on demand as well. You go to macrofab.com/webinars. A few hours from now, the webinar should be available on demand as well. And highly recommend everyone to go to both Macrofab and Xometry, create a free account, and see how the platform works. We are always available over here if you guys have any questions. Both the companies have a really solid support system. So once you are in the platform, if you have any questions, all your questions will be answered over there. So again, appreciate everyone's time, and we'll see you 2 weeks from now. Thank you so much.
Thank you so much.
Thanks, guys.